Doesn't it? All right, let's start with announcements first. Your homework 2 grades should be posted. If you saw my announcements, if you have less than 70%, all three of us have discussed your grades, and that's the grade we decide to award. So if you have 70 or less points before applying the late penalty, you can come talk to either one of us, and we should be able to do more explanation on why you got that grade. First thing that we're supposed to be doing right now is to go over homework 2. So if you can't see anything, you know what the homework is. I'm going to try and explain this on the board. So the first question was the cryptography problem. I know all of you enjoyed that a tremendous amount. And there were, when I designed it, the question, I had two main solutions I was thinking about. The first one is what the majority of you guys did, which is run the algorithm through a brute force solution and try to force the key. So let's go over how this protocol works, what sim.c actually does. It's a very simple protocol. It takes every 72 characters. Every character itself is 8 bits long. It chops off the first bit, the most significant bit, because ASCII only uses the last 7 bits. So that becomes 63 bits when you chop them 63 bytes, 72 characters, which is 8 bytes, turns into 63 bytes. I added a null character, so that becomes 64 bytes, and I XORed that with the key. And the key itself, as you may have realized, is actually only 32 bits long because top half and the bottom half are just the complements of each other. And so if you did the brute force solution, you should have realized that this is the pack function, then we XORed with the key, then we took the 63 bits and transformed them back to the original 72 bytes. This means that this is like the Feistel network that we went over in class of DES. This process is entirely reversible with the same exact code. So if you had the key, you can use sim.c to actually decrypt the message with the same exact code without modifying it at all. Does anyone have any questions at this point about what I just said? Okay, so now the question comes down to, if you didn't use a brute force solution, how else could you come to the conclusion of what the key was? And the idea has to do with these 72 bytes of characters. And what happens if you don't have 72 characters and you want to encrypt this message? The code will tell you that it gets filled with null bytes. So if I only had one character, let's say the A character, the rest of these characters are all zeros, right? They're all 0 bits. That's the whole null byte. And so when I XOR it with the key, something should tell you what would happen. What will happen? If you XOR something with 0, with x, that comes out to be x. And so what ends up happening is, if you looked through the ciphertext, which I was hoping to be able to show you, you would have realized that the last couple bits, I believe it was like the last 15, no, more than that. There were a lot of bytes. I believe like the last 15 bytes of the data were all repeated. So that should have told you that something was looking afoul because of this whole XOR operation. So you were able to retrieve the key directly just by looking at the ciphertext. It wasn't as simple as just looking at it because of how the code is compiled. It is in little endian form, and the fact that this key itself is doing this weird 8-bit right shift. So the solution is actually, you just take an A character and you encrypt it with some key, some random key, and you'll look at, you should be able to see the pattern of how the key looks like, and you should be able to apply that same pattern to the ciphertext to retrieve the original key. All right. It's very difficult to show you when I don't have a projector. So that's how you're supposed to, you're supposed to solve question A, but again, I made sure there was a brute force method that you guys can use if you didn't come to the solution. So if you did the brute force method, you got full credit. if you implemented this solution, which some of you did, you got extra credit. And oh, by the way, there are some sample reports that I posted on Canvas that you guys can take a look at for your reference. Please make sure that you have your executive summary analysis on all your reports. That's very critical. It's easy points. Please do that. All right. Any questions on the first homework 2 question? Okay, so I'll keep going. Question B, there is a hidden flag inside the program vol. How do we get to it? So if you run the program through GDB, you should be able to see that it asks you for this trapdoor address, and you can actually just call the trapdoor function with a call function, actually. So that actually does work. So I believe it's something like you can just call void trapdoor. I believe this would actually just call the function on GDB. The other way to do it is to run it through disassemble, find the address. I believe without reference it's 1189, and you can just type that address into, well, you also have to find the original offset as well.
Yeah, you have to find the offset. The other solution that I had in mind when I was designing challenges, you can start the process, and then while it's waiting for you to put some input, you can actually use GDB to attach to a currently running process. So you have to find the process ID of vol, you can attach to it, and from there you can print the address of trapdoor, which would give you like the actual address, not the non-offset address. That was kind of hidden. The offset would change every time, so you can just jump to it while running. I think Ethan, when he was trying to solve it, he just disabled address space randomization, which you can do. You can disable it on your computer for running a process, so you could also use that to find the address.
Yeah, I don't know what's going on with projector.
Yeah,
All
I
right.
I called the hotline and they're not here, so I left a voicemail.
Oh.
Which, one step below getting an actual person pulling up, but
Okay.
such is life.
Wait, it was just a voicemail? It wasn't even a...
I left the voicemail. They didn't
Okay.
pick up.
All right, so question C, the buffer overflow attack. You could have thrown this into some sort of decompiler, and it would have shown you that there were 2 buffers. The first buffer was 1024 bytes long, and then there was another one that I already forgot how many bytes long there were, but something over there. The important thing is that you figured out that the first buffer was 1024. You can also use something like object dump to dump out the assembly instructions, and you would have also found that there is this offset. I think it's like OX400 or something. And you have found that the first buffer is 1024, and when you did the fgets to read in the so-called password, it would actually take in 2048 bytes. And so therefore, you can actually just overflow this whole buffer and make sure that whatever was in the front of the buffer with null bytes was exactly the same as the second buffer with null bytes. And the actually easiest way to do it is just cat dev null. So /dev /null is actually just 0 bytes. And so if you cat this and you took 1025 bytes of the data, you would have overflowed this first buffer with 1024 null bytes with an additional one over here, which means that you're just going to be comparing 2 empty strings to each other. And so that would have yielded the correct password because the comparison is equal, and so that would have been a legitimate buffer overflow. A lot of you guys decide to put in some password like password, and then back calculate it. So if there's 8 characters, so that's 1024 minus 8, so that's 1016, minus 1 for another null character, so 1015. So then you did all that math, and then you figure out what's the offset to put in password for the second one with the null character. All of those are valid solutions. So what's the easier way to obtain the flag? Well, if you did dump it into something like a decompiler, you would have immediately saw the plain text of what the original password was. The alternative way, if you didn't do that, was you could use the strings command, which would try to find all the original string, like ASCII-looking characters of any binary file, and you would have also found the password that way. You could, again, also throw that back into object dump and found all the hex characters, and you also should have been able to reverse engineer what the original password was. So that was the extra credit question. I know all this was a little hand-wavy since I don't have a projector to show you anything, but if you have any more questions, I'm happy to answer them here or after class. Any questions about the homework? All right, well, good luck with assignment 3. It is due tomorrow. Yeah, please make sure your report has to have evidence. If you don't have evidence, it's very hard for us to grade because we don't know how you came up with the solution. We don't accept magic as an answer. So, yeah.
I guess the easy way to run through it in your head is if you gave this report to someone like Bishop who doesn't know what our assignment is, Matt Bishop, would he be able to verify and look through it and say, is this chain of reasoning valid? I'm sorry to say, like, think of it as a mathematical proof, but I mean, yeah, think of it like a mathematical proof where show your steps and provide evidence for your steps.
Kind of just like how in any class where if you have, like, if you're writing like an essay or something and you want to prove a point, then you have to have evidence that's going into your argument. So it's kind of just like that. We have to have something that we can go off of when we're grading. Okay. I got the driver set up just now, so it should be good. I'll get started in a second. If anyone has questions on the homework while I do get this set up, and I do kind of want to wait for the projector to get set up before I go really into the lecture. So for the time being, if anyone has questions about the homework, then we can talk about that right now.
What building is this?
Caress Hall.
107.
Okay. Nothing?
Yeah, no one.
Okay.
You might want to just
Yeah, I can
live
get-
stream it,
To what?
like on Zoom or something, probably.
Yeah, I could do that. Pause. All right. Now we can actually start lecture 11, about 20 minutes late. We'll be talking today about offensive tooling, so sort of like a more intro to the hands-on side of pen testing. There's a few commands that we're going to discuss today that would be nice to have. If you have a shell open, that would be good so that you can kind of demo it. The stuff that you might want to install going into this would be so if you have like WSL or if you're on Mac, then I think you can install this with Brew and Map. We covered this a couple lectures ago. I'll talk about it on the next slide. But that would be good to install to kind of try out. In fact, let me check if the demo is open yet. Okay. I'll just get into it, but yeah. Nmap is a network scanning tool that allows us to find systems on a network, find ports running on each system, and find info about the services on each port. Long story short, it's just a way to find more information about the types of computers that are running on some type of network. The command is pretty simple. You just type nmap and the network that you want to talk about. Recall from the server operation lecture that a network is usually specified by an IP address and a mask after that. So, for example, 192.168.0.0/24. That would be one network. Does anyone remember what that /24 refers to? Yeah. Were you raising your hand or no? Was that like an unconfident?
Yeah.
You can go for it if you want.
It's the net mass, so it's specifically the amount that just doesn't, the amount of bits designated for the host.
Correct. Yeah. So /24 is referring to the number of bits designated to the host. The 24 itself refers to the number of bits actually for the network. So it means that there's 24 bits for the network, which is 8 plus 8 plus 8. And then the remaining 8 that makes up a 32-bit IPv4 address refers to this part, which is the host part. So any address that's in 192.168.0.0 all the way to 192.168.0.255, which is, remember, 8 ones strung together, is referred to by this notation. And so it's a neat way to refer to a whole range of IP addresses. Yeah. So when we're running Nmap and we type in a network like this, what we're essentially saying is we're asking Nmap to scan this entire network to see what's running on there. By default, Nmap will scan all systems on a network and check for the most common 100 ports. So it does a TCP scan and sees the top 1,000 and checks for those top 1,000 ports to see what may be running. And we can try that out right now. So there's a few flags, but I'll get to that in a moment. Most of you guys have your laptop out. I have a demo prepared, so you'll have to disconnect from Eduroam and connect to my sketchy Wi-Fi SSID. Do you guys see, if you like go to the Wi-Fi menu on your laptops, do you see ECS198F lecture? Not yet? Oh.
Yes, no.
Wait, sorry, it's going to go down and come back up. Okay, see now? Yeah, it is the cybersecurity Okay, so the password is, I'll just put it on the board. Actually, I can just say it out loud. I was not very creative, but it's welcome. 1, 2, 3, 4. Are you able to connect? No, it's connected to the Wi-Fi to the internet, so you should be fine. Well, let me know if you do lose access, but you should be good. Let me connect to it on my laptop as well. I'll pause the. Okay, sorry about the pause. So, Nmap has a few flags. Let's first try just a basic scan and see what that takes us, and then we can continue. So, I have a Kali virtual machine that I will use for this demo. So let's see. Let me make a new tab here. And the IP address that we are using for this demo, I'm just going to type IPA, which in Linux expands to IP address. I have this grep here just to remove the MAC addresses. And you can see that this is the subnet that we're on. And if you run ifpconfig on Windows, or if you're on Mac or Linux and you type ifconfig, then you should be able to see a number that kind of looks like this, 10.42.0.something/24. Again, it's /24, which means that that last part of the IP address, those last 8 bits, can change, and it'll still be on the same network. And so we're going to run a scan on this just to see what's on this system, on this network. And actually, this would have worked until just now because the Wi-Fi just went down. Why did it do that? Okay, well, whatever. We can run a simple scan. So I'm going to type nmap. I'm going to put in this, and I'll change this to a 0 just for consistency. And let's see what this does. Right now, I'm basically scanning all of our laptops, but you're not going to see anything interesting, really. It always takes a little bit to run. And if it takes too long, I'm just going to run it on my laptop instead, actually. Let me just do that. Nmap 10.42.0.0/24. Okay, and this is all we see. All we see is my laptop, and it's showing a few ports are open. Is anyone else connected to it? No? Did it go down or?
Yeah, it went down for me too.
Ah, what? Okay, one sec. Okay, I forgot to unpause the recording. So the thing that just happened in the last 2 minutes was running an Nmap scan and seeing this is the ports that we have open, and we have this device over here. Anyway, so we see that there's some ports open. By default, the thing is with Nmap, it will only scan for the 1,000 top ports. So SSH is a very common service to have on a network, so that's in that list. HTTP is a very common service, right? It's the backbone of the web, so that's on there. And so we saw those services on there. 2222 is also commonly known to be like a alternative to the normal default SSH port, so that's on there. But this isn't super thorough. Does anybody know how many ports there are in total? If you like know the number, it's 2 to the power of 16, which is 6,000 or 65,536, or technically it's 535 because 0 doesn't count as a valid port number. So that's a lot, and we're only scanning 1,000 out of all of those, which means that if you choose some random port number like 60007 or something, then that wasn't supposed to be a 670. Okay, if you scan some port like that, then that might not be in that list. So if you want to run some like super suspicious service, then you could hide it from that top 1,000 port and get away with, and have like rest assured that the default Nmap scan will not catch it. So instead of going with the default, just the top 1,000 ports, we can append some flags. So if we append -p-, then we start to scan all of those ports. So instead of just scanning top 1,000, we're scanning 65,000. There's a few other flags that can give us some more specification. So for example, -sv will give us the service version. Right now, all we know is that we see port 22 is open, we see port 80 is open, but we don't know what's running on those. If you really want to, you can run an SSH server on port 80, and it's being identified as HTTP just based on the port number. But it's not, the Nmap is not actually looking into the service that's running, and so if you just run an Nmap scan, you might not get the default Nmap scan, you might not get all of the information that you want. So we can append some flags to this, right? So let me recall this command. I'll hit Control-H to go to the start. And I just want to find more information about this device in particular. So instead of scanning the entire network, I'm going to remove the subnet mask, and I'm going to just scan for this IP address. Then I'll add some flags here. So let's do -sv to find some some information about the services that it's running. So let me do -sv. And then I'll do -p- to scan all of the ports. And this will run for a little bit. So in the meantime, let's just do some more exploration on what's on this computer. OK, so let's first, we saw that there was SSH running. We saw that there's HTTP running. It's pretty easy to just go and look at what's on the website. So let me go ahead and type in this IP address into the search bar. So it was 10.42.0.65. I'm going to copy that, go here, and I'll paste it in. And OK, we see that there is a website running, and it just looks like, it says default page at the top. It says Apache 2 default page. Apache is a common web server that's used throughout the internet, and this is just the default page it looks like. We don't really see anything interesting here, but we do see that this is running. And this brings us to the next tool that we have called GoBuster. So right now, all we see on this page is whatever's on the page itself and whatever links there might be, right? So we see there's this link here, which takes us to, I guess, apache.org. And I guess this is how I find out I'm not connected to the internet right now. So it takes us to apache.org, and that's not on this page, so we're not really seeing anything super useful, but let's see what other links there might be. Bug reports, that takes us to, it says in the bottom corner, launchpad.net. So again, we're not finding more stuff that is on this computer, that's on this system. And so there is a chance that maybe there's other pages that are on this web server that we just can't see because they don't have links that are taking us directly to them. So GoBuster comes in order to try to solve this problem. So it's a way to brute force finding website directories and subdomains. Directories are parts of a website that are like, we call them just pages, right? So for example, if you have daviscybersec.org, the club's website, and I'm not connected to the internet. Why? OK. Whatever. If you go to /about, you can just try this on your own laptop. That'll take you to a distinct page. And so that counts as a directory in the same way that like a file path counts as a directory, right? So there's also subdomains. So we use daviscybersec.org as our club website. If you want to go to the course website, then you append you prepend ECS198F, and this is a subdomain. So unless you have a link to a page, or you will never be able to find out what the directories or subdomains of a page are without brute forcing. There's just no public listing of these. They're meant to be unlisted. And so that's why things like unlisted Google Documents work. They're just subdomains on the Google Docs link that you can't find unless you guess those like 128 characters that are being used in order to generate a unique link for each one, right? So without having a link to an unlisted document, you just don't know it exists. And that's why you can brute force for them to try to like circumvent the fact that there are no links, direct links to them. Any questions about that? The idea behind GoBuster? Okay.
Don't run GoBuster on random websites. That is illegal.
I'll echo that for the video. Don't run GoBuster on random websites. It's illegal. So always stay in scope. Don't run GoBuster on our website either. Those are both one of them is hosted on GitHub, one of them is hosted on Cloudflare. They will not be happy. It's Microsoft and Cloudflare. They will not be happy if they think they're being attacked. So yeah.
Jail, it's for a project.
Huh? Jail?
It's for a project.
Yeah, it's for a project. Our course will not bail you out. I'm sorry. So let's go and run GoBuster on this website. This is our scope. This website is our scope, so we can just run that freely. I'm going to use a Kali VM for this. And let's just make sure we're still connected. Yep, we are. Okay, the demo is working for me today. This scan is still running, and I can see it says about 5 minutes remaining. Okay, it's lying. It's going to take like 10. Let's run GoBuster on this. So the syntax for GoBuster is, especially since we're looking for directories, since we're targeting an IP address, it doesn't actually have a subdomain. Subdomains are for things like that actually have domain names listed, like google.com is a domain. So drive.google.com, which is Google Drive's link, will take you to the subdomain for that. But since we just have an IP address, we actually can't do a subdomain brute force because subdomains don't exist for IP addresses. So instead, we can just focus on this directory brute force. We can do GoBuster directory. I guess I'll just copy and paste it. Okay. Go in here. And let me set the website to that IP address we had, right? It was 10.42.0.65, I believe. And then we're given this option to put a word list. So in order to do any type of brute force attack, you always have to have a list of words that you are feeding into the brute force. So by default on Kali, or not by default, if you install the seclists package on Kali Linux, and for all of the assignments, you will all have these lists installed. That package will install a few word lists into user share word lists. The point of these is to act as an input that you could feed into any type of command. For example, GoBuster, or if you're doing password cracking, then you could feed these word lists into those commands in order to have a list of words that can be used in order to do the brute force. So actually, before I run this GoBuster command,
The word lists are in user share word lists, but seclists specifically installs the user share seclist.
oh right, you're right. Does word lists are there by default?
Word lists are there
Yeah,
by default.
okay.
I think it's just blocked you, but
Okay.
you can go and check it out.
So let's just look at what's in here. So user share word list has this. The one that we want to use is in dir.b, and I'll type. Let's see what's in here. So common.txt is like, obviously, as the name implies, it's the one that we might want to use. And I will type view in order to view this in the text editor. And you can see that these are the words that we have, right? So it's all listed alphabetically. And there's a lot of stuff in here.
I mean, if you look through websites or their source codes, you'll probably end up seeing some of these subdomains at some point.
I'm gonna do word count -L in order to see what's on there, and yeah, there's like 4,600 words in there. So yeah, like Jason said, those are common subdomains or directories that are used on certain types of pages, and we can use this word list as part of our GoBuster brute force. So I'll type GoBuster dir -u. U refers to URL, so I can even expand that to URL. http://10.42.0.65. And then I put -w to refer to word lists, and you can also expand this out to, I think, word lists. Actually, I don't want to mislead you. I think it should be -- word lists, but I have -w prepared. And then let's just use that common one, right? So user share word lists. I misspelled that. /b/common, and I'll type tab to complete, and I'll hit enter, and it works pretty quickly, especially compared to the Nmap scan. So here's what we see. Let me make this bigger. So we see this index.html page, which returns a 200 code. 200 refers as a HTTP code for success. And then we see these other files that say 403. You can always Google the status codes, but instead of Googling it, you can also just browse to it. So let me just type in 10.42.0.65. Did I get that right? Yep. Colon index, or sorry, / index.html. Index.html is always the root page. So in fact, if I just remove index.html, and you can already see that it's like basically the same as what we already saw. Index.html just refers to the root. We also see these other files that give us 403s. So let me go to /server-status, and it says forbidden. Forbidden is the HTML code that is represented by 403. So there are a few files that we see that are just not there. So it kind of feels like this GoBuster was all useless because we didn't find any useful information other than just this index.html file, which we already knew was there because that's just the default page. And so this is one of those cases where you might say, okay, let's use a different word list. Maybe that was 4,600 words just wasn't enough, and we need something that's larger to work with. So let me go ahead and change this command from common.txt. I'll type tab to autocomplete, and we can see that there's a few other ones. For example, big.txt, which is probably more thorough. We'll hit enter now, and this will take longer to run. In the meantime, let me check how the Nmap's going. I'm not very okay. Still 5 minutes, as it goes. How's your guys' days been? I had this lecture that took about 50 minutes to get started. Okay. Okay. Interesting. Fascinating. So we see this grades page, which we didn't see before. Let's try browsing to that and see what happens. Wow. How did we find that? It was an unlisted link, and we brute forced it using GoBuster to find information that should not have been publicly available. So the idea here is that we're able to use GoBuster in order to find links that otherwise couldn't be found through the website. So yeah, let me...
Mary Gay is going to blow you up.
Any questions about GoBuster and how that works? If you're on the Wi-Fi network, I believe you should be able to try it. Although I don't think there's Wi-Fi access I don't think there's internet access on the Wi-Fi network. So it's kind of a half attempt. Okay. Let's suppose that you aren't just looking for pages, but you're looking for files. So what if you don't want to just look for pages that are on the website, but you want to look for like PNGs or JPEGs or PHP files? And we'll talk more about PHP, I think, on the next slide. There's a flag for GoBuster that lets you specify that. So if you put -x and then put a file extension, you can find that sort of information. So let me just first try it with PNGs. I never actually tested it, but I'm curious about what it would show. Let's do -x. Actually, let me change it to common first. Let's do -x PNG. Okay, again, we're seeing these forbidden files, right? 403s, index.html. I don't know why that showed up. Okay, interesting. So these are two files that we just wouldn't be able to access because of a lack of permissions. Let me change it from PNG to now PHP to find PHP files. And let's see what's on here. Okay, we're seeing a few things. We see exec.php here, and we see time.php. Before I proceed, let me just go to the next slide. So, never mind, we're going to proceed. So let's just go to time.php first and just see what this is. Time.php. Okay, it's the script here that just says, it just displays the time, and it shows the date, and it says whether the lecture has started or not, right? Like, let me just reload the page. Okay, the time's updating. It's like kind of dynamic.
What does the source code look like? I'm just curious.
It's just, I can show you after. Oh, I'll put it up on the course repo afterwards. So PHP is a dynamic website engine. If you looked at that page that we had just before this that just said, default page, there's nothing really going on here. We call sites like this static because they're just files that are being hosted with no actual functionality, no backend. The course website page, like our course website page, ECS198F.daviscybersec.org, that's also a static site. There's nothing really going on there other than just some files that are being hosted. And so if you check the page one day and then check it the next day, it'll be basically the same. There's no dynamic content that's being served. Whereas a website like Google, which has layers that include authentication and advertising and stuff like that, that's a dynamic page because things are changing based on who's accessing the content and what time they're accessing the content. It keeps track of more variables, and so we call those pages dynamic. PHP is one of the early frameworks that brought us dynamic pages. It acts as a middleman between databases, the operating system, and the web server itself. So it sits, you could say, below Apache, which is the web server by itself. So it has access to many different things, right? You can access the database, you can access the operating system itself, and so if it's misconfigured, then it can be very damaging. But this isn't to say that it doesn't have its uses. For example, if you wanted to have a website that just shows you the current time and whether we currently have a lecture, it works, right? I took this screenshot in the morning, no lecture in session. It does its job, but it's just that you have to be very careful about how you're configuring it, just with any type of code. So on that note, let's get into Netcat. So Netcat is actually, are there any questions about PHP and what it's used for? Okay. So Netcat is a utility that we have on Linux for opening network connections. It's a pretty simple utility, but it's very versatile. If you run nc, or 192.168.0.10, 1234, then you're just sending a TCP connection to this IP address with that port. If you use a -L flag, then you start listening. So you start accepting connections instead of being the one who's initiating them. So you could imagine a scenario where maybe you run 192.168.0.10, 4444. I can't edit it because I don't have internet access. And then you listen on your own on another laptop, and they'll be able to communicate because one laptop is listening for traffic, and the other laptop is sending traffic. And so they're able to talk to one another. So Netcat is just a utility for being able to set up connections. And it has many different capabilities, and so we use it as part of different types of exploits. So let's look at the other PHP page that we saw in here, right? We saw exec.php. So let me go ahead and browse to that. And here's what we see. We see execute commands. Note to admins, keep this page unlisted until safety checks are added, which is why we weren't able to see it until GoBuster was put up. So there's nothing else on this page, right? How do we execute commands? It claims that we can execute commands and that there's no safety checks, there's no guardrails set up. But how can we use them? Does anyone have any ideas? How else could we interact with this page? Okay.
There might be some query parameters that you can change that modify web behavior.
Right. So we can track query parameters. So query parameters are these things that you append to the end of a URL. You might have seen them before in, I think by default, a lot of, if you go to an Amazon page, for example, it should, I think it'll put query parameters at the end just to as tracking stuff. But they also have valid uses. So if you submit forms on old websites, they'll have the parameters up there in the URL. So for example, let's just, this is what a parameter would look like. Name equals Akil. That would be a parameter. This didn't change anything, so we can assume that maybe this didn't work, right? Does anyone have any ideas for what the query parameter would look like here? Let's say we wanted to execute the command ls to list files. What could the query parameter possibly be? Just combinations to try out. Given that we know that it's executing a command.
CMD?
CMD? Okay, that got us something, right? So we see exec.php, grades, index.html, and time.php, which coincidentally are all those files that we were trying to look for, right? So we're seeing information that we would want. We could also do ls-la, and this outputs it into the ls-la format, but clearly it's not a list. It's just being put into a single string, so it's getting something. Any other commands you might want to run? Non-destructive ones, ideally. Yeah?
That's high.
Touch high, sure, let's see. Okay, and now let's type ls and see if it worked. Okay, it didn't work, and I'll show you why in a moment. We can try echo. Hello. That worked. Yeah, okay. We can also probably try cat, like for example, if we did cat grades. I guess that didn't work. Interesting. So as you're given any type of environment and you find a hole, feel free to just, well, as long as you're in scope when you found that hole, feel free to just experiment and see what does work and what doesn't work. Any other just things to try before we proceed?
ls dot dot.
ls.dot, sure. One moment. ls dot dot. So dot dot means go up in the directory. So dot slash refers to the current directory, or dot refers to the current directory. Dot dot means the directory above where you currently are. And that shows us HTML. So yeah, that means that probably those 4 files that we saw are being stored in this HTML folder, which might have more folders above it, right? Like if we do ls dot dot slash dot dot, then we go one file folder even above that, and we see backups, cache, lib, etc. So this is very close to like the root of the system. There's one more level that we could do. Let's just do that for thoroughness. And yeah, if you see bin, then and mnt and run and things like that, generally that means that you're at the root of the system. And so even if I tried to do this one more time, it'll give us the same thing because you can't go above the root. Okay, that was a good suggestion. Any other questions or things to try? Or yeah.
Python malicious code. Cat that code into some file with equal redirection.
So we would want to put code into a file. Okay, I'll touch on that in a bit for why that might not work, but it's the same idea of doing touch high, where this wasn't able to do anything, right? Like it just, when we ran ls after running touch high, we didn't see a high file in there. And I'll talk about that in a moment. So, okay. I realize I'm talking about a bunch of random topics, but they'll all converge in a moment. So reverse shells are this type of attack that you can run on a system that allows you to basically bypass firewalls by forcing a computer to initiate a connection to you. So if you're trying to set up a shell on a computer, then there's 2 main ways that you can do this. The normal way, the ordinary way, is called a bind shell, in which you on your attacker's machine, that's you on the left, try to initiate a connection to the target server. But if the server has a firewall up, then your connection might get blocked, right? Maybe the only types of connections that can get through are web connections. So you can only access this server using your browser. You can only access it using HTTPS. But any other ports will get blocked. So if you try to set up a bind shell, then it will not be allowed because the firewall knows to block it. However, this target server usually has a one-way firewall, which means that connections coming into it will be blocked, but connections coming out of it will not be blocked. So if we can somehow convince this target server to connect to us first, then we can make sure that we're able to utilize that connection. Essentially, instead of having us set up the connection to the server, we're having a server set up a connection to us. And we're able to use that because that goes through the firewall. Any questions about that concept? Okay. Yeah?
Don't firewalls usually also have outbound logging?
Yeah, so this is we're talking about like a sort of naive case, but if you're setting up a firewall on your own laptop, for example, usually you would want yourself to be able to do basically anything, right? Like if you're running a server on your laptop, and you know that this laptop needs to have access to the internet, then you're going to allow access to everything on the internet. But then you're going to restrict connections to your laptop. And so by default on most operating systems, the firewall looks just like that. So what that means is if you're on like a public Wi-Fi network, like you're at a coffee shop or something, then connections to your laptop get blocked, but your laptop is able to access anything in the internet. So it's a one-way firewall so that you're able to do whatever you want, but people aren't able to do whatever they want to you. So if they are able to find a hole in, then that could cause potential issues with reverse shells and things like that. The reason why this is more of an issue for servers rather than normal laptops is that you and I, we're not running web servers on our laptop all the time, right? Like I am for this demo on this laptop over here, but that's not something that people just normally do, right? Like you don't go to the MU and say, hey everyone, I have a website on my computer, please connect to me. Usually your laptop is just a client, so it's just connecting to other websites on the internet, like you're going to Canvas or you're going to YouTube or whatever it might be. You're not setting up connections on your own laptop, and so this potential for a reverse shell doesn't impact you and I. It impacts public servers. So potentially, like Google, if they had a flaw in their code, then someone could find a way to set up a reverse shell on their servers. Good question, though. So yeah, essentially, we do have outbound firewalls, but usually for just normal systems, it's kind of an afterthought. Okay, we can proceed then. So we found that there's a hole in this system, right? We're able to execute whatever commands we want on this computer by taking advantage of query parameters. So we could possibly set up a reverse shell on our laptop if we first use netcat to set up a list. Or sorry, we could possibly set up a reverse shell on the target system if we can get it to first of all, we'd have to set up a listener on our own laptops, right? We would have to listen for connections on some port so that the server can connect to us. And secondly, we would have to somehow get the computer to connect to us. And so there's this bash command that I've put over here. What this says is bash-i, which means interactive mode. This whole command, I'll preface this by saying, is in order to get us shell access on this system. So in order to give us access to a shell, kind of like how you're able to SSH into the Kali VMs for the assignments. This would be a way for us to try to get the system to give us access to a shell that we can use. Although it wouldn't be through SSH, it would be through this exploit that we're trying to find in PHP, or in the PHP code that they've written. So bash-i is that shell itself. It's just the interactive bash command. So for example, if I went into my laptop and typed bash-i, it would just put me into a bash prompt that I could use. So this is just bash. Before that, I was using fish, which is why it looks different. But this is really just no different than just having an interactive bash shell. We see this redirection into the ampersand. What this means is to capture standard output and standard error. So we're just redirecting everything into this file. And there's this file here that says dev TCP. We see an IP address here, and we see 4444. That IP address was just my local IP address at the time. But if you can try to get it to connect to your IP address on port 4444, which is the port that you're running on, and then have this redirect at the end, which says to redirect standard input to standard output, then this is basically a long way of saying, give us a shell, redirect it to my computer, and have it redirect standard input, the standard input from my computer to its standard output. So we're giving us a way to, from our laptop, type on our keyboards and have that output show up on the other system.